Hi, so I think you've pretty much got a, a personal presentation on OpenCDM. Okay, so my name's Peter, I'm the tech lead of the Multimedia Working Group. This is an update on the work we've been doing with OpenCDM. The various engineers involved are going to present on the bits of work that they've been doing. So there's Alexandra, Andre, and unfortunately Shiva can't be here today, so I will cover his parts as best I can. So a quick agenda of what we're going to cover. It's going to be an overview of OpenCDM, the status of the Chromium 65 support that we've been working on, a look at how we're integrating the secure buffer allocator that Alex has been looking at. Then we're going to have a quick look at the Chromium GStreamer backend, which is what we're hoping will be our full SDP solution. And then a look at the work we've been doing on the WPE Browser, which is the WebKit port optimized for embedded devices. So the background to this is LHG, previously, and now MMWG, have been developing reference solutions for our members that for the playback of encrypted media content using OPTI and TrustZone. So we've been doing this with PlayReady, Widevine, and ClearKey. Much of the work previously was focused on Android, which has a kind of more defined DRM framework APIs with the Media DRM and Media Crypto plugins. But recently, we've been trying to take like the full secure data path solution that we had under Android and get something similar working under Linux. And the main focus on Linux has been the support of encrypted media extensions inside Chromium and WPE browsers. So what is EME? Well, it's a proposed recommendation from the W3C to extend the HTML media element to allow the playback of encrypted content. Most web browsers support this. And this is a diagram taken from the standard that kind of shows an overview of the stack. So you have the web application calling various methods. Eventually that cools down into the content decryption module. And it's the content decryption module that we've been kind of implementing and for various key systems, which then goes off to OPTI. So what is a CDM? Well, it provides the functionality of the target hardware to implement a key system such as PlayReady or Widevine. The spec also mandates a clear key, which is where the video is still encrypted, but the actual decryption key is well known, and that allows us to provide these reference solutions that are totally open source. But the data flow is exactly the same as with a real proprietary system. So the other reason we're doing this is on embedded devices, we want to have zero copy pipeline to avoid any CPU copies. Quite often the SoCs have hardware to accelerate the decryption operations. So on the NXP platform, it's called the CAM. So we want to get that integrated into OPTI and using that, and also to play back like the 4K content. We want the decrypted buffers to be protected by some sort of firewall IP so that the host can't dump the video and break the security. So it's these things that our reference solutions are trying to address with OPTI. So OpenCDM. So CDM is the content decryption module. Open means that it's open source. Microsoft had a specification called the Content Decryption Module Interface specification, and it's a specification that tries to allow open source browsers to expose a defined sort of interface, and then different key systems can implement that. And OpenCDM is an implementation of that specification. It was originally implemented by Fraunhofer Focus. I'm not sure if I pronounced that correctly, but they didn't really maintain it that much, and it led to several forks, one of which inside Linaro, where we focused on getting it working well on ARM and ARch64, also the integration with Chromium and supporting OPTI as the trusted execution environment. The WPE metrological folks also took it, and they were using it with their WPE browser. And then lately what we've been doing is trying to unify those forks, so we now have one plugin that we can use with both browsers and support multiple key systems. So this is just a quick overview of the kind of architecture. The OpenCDM plugin lives in the browser, and then it talks over a kind of RPC or IPC mechanism to a CDMi service, and in that daemon is the kind of glue code that then talks to either the play-ready porting kit or the Widevine CDM that Google provide, and eventually that filters off over into the trusted world to do the decryption. So this is another diagram of the plugin. It's kind of quite well partitioned into different layers. We've got a browser glue layer, which is where we put the Chromium and WPE parts. There's the core that hopefully we don't have to change very often. And then the communication mechanism, which at the moment is using Sun RPC, but we'll come back to that point later. And on the other side is the CDMi Service. This is kind of basically that stack upside down. So we have the RPC mechanism coming in that then talks to the DRM. At the moment, we can only kind of compile one key system in at a time in this setup, but we're looking at a multi-DRM setup where it will instantiate the kind of correct DRM scheme for the content that's trying to be played. And all of this stuff is on our GitHub page, where you can see the links there. Okay, so that's a brief overview of what OpenCDM is. Now, Andre is going to talk about the work he's been doing to get this working on Chromium 65. So originally we were based on Chromium 53, and then Alex afterwards is going to talk about the work he's been doing with the secure buffer. Okay, so I'll hand over to you, Andre.
Thanks. So I had a session yesterday, so this will be a short summary of what has been done to support Chromium version 65. Actually, version 65 is not something special. It was just the most recent version at the time we started doing the update from version 53. And version 53 is actually a special one. And this is the last Chromium version which supported GIP build system. And for this reason, we were not able to move further because OpenCDM plugin did not support it near GN build system. And just to be able to move forward to the more up-to-date and current versions of Chromium, we needed to change this and update OpenCDM to use GN. And as we rely on external clear key CDM implementation in Chromium, for OpenCDM as well, there were some changes to OpenCDM to account for the changes in CDM interface in Chromium version 65 versus version 53. It has been done right before the connect, and now we have OpenCDM enabled in the builds we do in Jenkins. So Rocker-based builds for high-key now have OpenCDM support again. And as OpenCDM is tied to particular Chromium version, now we have two different branches in Linaro MMWG OpenCDM repository. They are named after Chromium version, so it's easy to find them in the repository. But at the moment, the version for Chromium 65 misses some functions present in version 53. We didn't implement play-ready support for version 65 yet. And the changes to unify OpenCDM implementation between WPE Browser and Chromium, they haven't landed into the version 65 branch of OpenCDM. It was kind of work going in parallel, and I just missed those modifications in the 65 branch. And as the build system changed, we also lost the possibility to build a debug version of the OpenCDM plugin while doing a release build for Chromium. It was a convenient feature because doing a debug build of the old browser isn't simple. The main problem is that you will get a huge binary. You should put into target somehow. So the possibility to use release version of Chromium and still having all the debug symbols for the plugin is a useful one, but it could not be just carried forward as is due to the changes how debug build is implemented when using GIP and GN. And that's basically it from my side. If there are questions, I can answer them now or after, in the end of the session. So I'll pass it to Alex. Thanks.
Hey, thank you, Andre. So my name is Alexandre Judra. I am an XP assignee in the Linaro Multimedia Working Group. I will talk to you about the ION integration in OpenCDM. But first, I will introduce with a brief summary of our work in Secure Data Path on Android and Linux on NXP IMX8M. Then I will talk about the implementation and testing of ION integration in OpenCDM. At the last Connect in Hong Kong, Cyril Fleury from NXP presented our solution for Secure Data Path on Android. It supports play-ready DRM and Widevine DRM. It has ION buffer integration, and it takes advantage of Opti SDP extension. It features end-to-end secure data path, meaning it, including the TrustZone address space controller, and it features secure data path including memory protection from TrustZone address space controller and resource domain controller. The solution, the SDP solution on Android doesn't use OpenCDM. Currently, we are working on a secure data path solution on Linux. This is a work in progress. We currently focus on Chromium, but we are planning to add the support for WPE Browser in the future. For VPU acceleration, we selected to use a GStreamer. We needed to integrate GStreamer into Chromium, and we take advantage of an implementation from Samsung called Chromium GStreamer Backend. The secure data path on Linux use OpenCDM, so we needed to integrate the ION buffer into OpenCDM. And also, we'll need to do OpenCDM integration into Chromium GStreamer backend. This is also a work in progress. The solution, we're focusing on play-ready DRM for now, but we plan on adding wide-band DRM support later. So here's an overview of the architecture on how OpenCDM integrate into the system. On the top, we have the browser layers, including the integration of GStreamer using the Chromium GStreamer backend. Here I've included a simplified GStreamer pipeline, including some of the key elements, including the demuxer, the decryptor, decoder, and display element. On the OpenCDM integration, there is two aspects to consider. There is the license acquisition, which is directly handled by the CDM plugin at the browser layer. And then the second aspect is the decryption, which is handled by a new decryptor element in the GStreamer pipeline, which take care of calling the decrypt API from OpenCDM. On the OpenCDM side, there is it communicates through RPC to the CDMi Service, which run in a separate process. And then on the CDMi Service side, each DRM implements their solution, including the communication to their corresponding trusted application, using the OPT mechanism, the mechanism provided by OPT. So in the context of secure data path, we need to do the decryption of the audio-video buffer into secure ION buffer. So that means the ION buffer need to be communicated from various layers, starting from GStreamer through all the layers up to the trusted application where the decryption occurs. Communicating that ION buffer at the DRM layers, we are reusing our integration of ION that we did for the Android SDP solution. But on the OpenCDM side, there was a need to implement a mechanism to communicate the ION file descriptor from OpenCDM to the CDMi service. For that purpose, when we create CDM session, we establish a Unix socket communication between OpenCDM and the CDMi service. And at every decryption operation, the ION file descriptor is communicated via this established connection using the socket ancillary data, allowing CDMi service to get access to the ION file descriptor. So as a summary of the implementation, the ION file descriptor need to be communicated through various layers, starting from a GStreamer pipeline up to the trusted application where the where the decrypted buffer are copied into the ION buffer. We needed to do the validation of of our ION integration at a point where the end-to-end secure data path was not completely implemented, or on system on chip which doesn't have any hardware protection for the memory, such as TrustZone address space controller or RDC. So we came up with a concept of OpenCDM SDP prototype. For the purpose of the prototype, we are disabling the hardware protection on the ION heap. This is to allow the CPU to map the memory, to map the ION buffer into memory, get a virtual address. Let me go into more details of what is the prototype. The concept is to be able to validate our ION integration, but it means at the GStreamer level, GStreamer pipelines run as is, it's running in a non-SDP use case. But on the OpenCDM layers, it's running in the secure data path use case, meaning it's dealing with the ION buffer and the decryption occurs into that ION buffer. So at every decryption operation, OpenCDM will allocate ION buffer. It will pass the buffer using the mechanism I described before up to the trusted application. At the trusted application layer, it does the decryption into the ION buffer. And then coming back to OpenCDM, OpenCDM would map the memory of the ION buffer. This is possible because we have disabled the hardware protection for the test purpose. And then mapping that memory gets a virtual address that could be used to copy the data to share memory. Once that the decrypted data is in share memory, the GStreamer pipeline can run just like in the non-SDP use case. So in summary, we are able to play back a stream using GStreamer in the non-SDP use case, but allowing to validate that our OpenCDM, to validate that our ION integration in OpenCDM and in the DRM layers are properly working. So is there any question? Then I'll let Peter talk about WPE and OpenCDM.
Okay, so unfortunately Shiva couldn't be here today due to some visa issues, so I'll try my best to talk about his slides, but it's not something I've been working with a lot. So WPE is the WebKit port optimized for embedded. It's used in the Comcast RDK. It's a lightweight, small footprint web browser that's quite fully featured, and it's attractive for embedded developers because it has very few dependencies. So we've been using it in Linaro in conjunction with the Westeros Wayland compositor, and as we talked about earlier, we've unified the kind of OpenCDM and Chromium OpenCDM plugins into kind of one plugin that supports both browsers. But this has actually been on an older branch that supports EME v0.1b of the specification, and that's what we've been using with PlayReady and ClearKey up until now. So obviously that branch is quite old, and we want to move to the latest tip of tree code. So we migrated over to the 2017 branch, but what Metrological have done here is there were some perceived kind of problems with OpenCDM, specifically its use of Sun RPC mechanism that's got some security vulnerabilities. And also the code base is quite large, so they've moved to a new CDM mechanism that still uses the the CDMi specification, but is kind of a bit more lighter weight. So there's some work ongoing at the moment to move over to this new CDM for the WPE browser and get that working with Opti and the PlayReady and ClearKey trusted applications we have at the moment. And that work is ongoing at the moment. In fact, I found out this morning that some of this stuff has been pushed onto the Metrological GitHub this very morning, so it's kind of stuff that's very actively being worked on at the moment. One problem we have had is the RDK is mainly in 32-bit, so we've had some problems getting 32-bit blobs for some of these 64-bit platforms. So this is an overview of this new CDM mechanism. So they've replaced Sun RPC for the IPC, and instead they're using domain sockets. But it's still a plug-in based architecture, and I believe this already supports multi-DRMs, so they have a kind of factory class that instantiates the correct plug-in depending on the content type. Our plans related to this, once we have it all up and running, is to get it working with the TAs that we have, and then also take the work that Alex has done with the secure ION allocator and integrate that into this setup as well. So I should have mentioned previously, one of the big advantages of WPE is that it natively supports GStreamer as its multimedia backend. So we get to leverage all the hardware codecs and things for the video playback. So IMX AM is the main reference platform that we've been using. This is moving on from the high key that we were using before that didn't have any hardware decoders, or not any with any open source software at least. So we now have a 64-bit version of Westeros and WPE running. Shiva's submitted the patches for this up to Metrological, and I believe they've been merged. On the older 2016 branch, we have it working with the unified OpenCDM and playback with PlayReady and ClearKey, and on the new CDM architecture that we briefly talked about there, we're in the progress of getting PlayReady going at the moment. So this is a kind of matrix of what's working on what. On the 2016 branch with OpenCDM, we have PlayReady and ClearKey. PlayReady working on both. On the 64-bit, we haven't tested the ClearKey. And on the new branch with the new CDM architecture, we're still sort of bringing that up. The code's only, like I said, only become available in the last few days. And then the plans moving forward on that are to get the full secure data path pipeline that Alex was talking about, working with WPE as well. Up until now, the Opti Widevine solution we've only had it working on Android, so we're going to move that across to Linux as well. Yeah, and that's the end. We finished a little bit early, but yeah, I don't know if you have any questions.
Hello, my name is my name is Modest Civic. I'm working for Sky Broadcasting in the UK. Some things I'm a little interesting about OpenCDM. Currently, Sky do a new set-top box, Android TV. When that will be made and will be, I don't know exactly when will be sent to German version. So that I'm here, something's heard. I would like something heard about something what is going.
Okay. Yeah, so on the Android side, Alex linked to some demos and presentations we did at the last Connect. So all these trusted applications with Opti and the SDP extensions we're using in Android as well, but because we kind of got that working now, we've moved over onto the pure Linux RDK side. I think you can probably turn the recording off now and maybe have a bit more of a informal chat.